Hey everybody, welcome to your Chapter 7 test review video. This chapter, as well as your upcoming test, will cover exponents and scientific notation. Now, I've been very impressed with how quickly you guys have picked up these skills so far in class and on your homework. So this video is really going to focus more so on some of the challenging question types we might see for this chapter. So I have a couple suggestions before we get started. First of all, if you are feeling really confident with this chapter, then I encourage you to use this more as a study guide and answer the questions first before watching my explanation. Also, if anything in here is feeling a little fuzzy or confusing or just a little cumbersome for you, please let me know, and you and I can work one-on-one to kind of revisit and work out some of those kinks. So with that being said, let's dig into, first, the basics. So we have learned when working with our exponents, there's going to be a couple rules we have to use. First, when we are multiplying variables that have the same base, we add the exponents. For example, x squared times x to the third power. When they both have the same base, we're going to add the exponents, so we would get x to the fifth when we simplify. Next, if we're dividing variables with the same base, we are going to subtract exponents. So x to the fifth divided by x to the third. I'm going to subtract 5 minus 3. I'm subtracting my exponents now, and we get x squared. Now, if we have an exponent with another exponent, a power raised to another power, we are going to multiply the exponents. So, for example, if I have x squared raised to the third power, we multiply 2 times 3 and get x to the sixth. And lastly, if we have an exponent outside parentheses with many terms inside, we want to make sure that we are sharing that exponent or distributing it to all the terms. So let's jump into some examples and see how we're going to apply these rules. So starting off, number 1, I see I have 3 terms I'm multiplying. So first we multiply the constants in the front. So that'll be negative 5 times 4 is negative 20. And then I want to match up my matching bases. So I have x times x squared. And then y times y to the fourth. Y. So from here, I'm going to remember, what do I do with my bases and my exponents? Well, they're matching bases, so I'm going to add my exponents. But before I do, I need to remember that even though my x and y don't have visible exponents, they do have that invisible exponent or power of 1. So when I add my exponents, I get negative 20 x cubed y to the fifth. And that would be my final answer. Next, I see that I have a problem with a negative constant, a power within the parentheses, and a power outside of the parentheses. So I'm going to start by distributing that exponent 2, that power of 2, to everything inside the parentheses. But remember, if the negative sign is inside the parentheses, it is attached to our constant. So this would be negative 3 squared. A to the 1 times 2, because remember, if it's a exponent outside parentheses, we multiply, and b to the 4 times 2, to the power of 4 times 2. Now, when we square a negative, the negatives cancel out, so this would be positive 9, a squared, b to the 8th. Next up, I see something a little trickier. Now I have a negative constant and a fraction, as well as a power outside of the parentheses. So first thing I'm going to do is address the exponent outside of the parentheses. So I'm going to distribute first. That will become negative 25 squared. A, now when I'm distributing, I multiply, so that'll be 2 times 2. And then B to the 1 times 2. Now, the next term didn't have any exponents, so that's just going to stay 1/5 A, B, F. From here, we're going to square negative 25. We get positive 625. A to the 4th, B squared, times 1/5 ABF. Now, when I'm combining like terms, because I'm not done, I haven't fully simplified until I've combined all of the like terms, I'm going to first multiply 625 times 1/5. Now, we've learned when we multiply by a unit fraction, meaning 1 over another number, we are just dividing by that denominator. So 625 divided by 5 is 125. And then I'm going to look at my bases. So now each base has an exponent and the bases are matching. So this will be a to the 4 plus 1. When they each have their own base and the bases match, we add the exponents. But remember, there's always those invisible 1 exponents when you think that there is no exponent. So we get a to the 4 plus 1, b to the 2 plus 1, and then just f to the first power. So from here, we simplify 125, a to the 5th power, b to the 3rd power, f to the 1st power. Now, the next question is division. So we want to remember when we are dividing, we are subtracting the exponents. I also see that I have some exponents that are negative. Now, before I do anything with those negative exponents, I want to simplify them with that subtraction we talked about, because sometimes when we subtract the exponents, we end up canceling out the negatives anyways. So we're going to save that negative exponent step till the end. And I'm going to start with negative 6 over negative 10. Now, in this case, they're both negatives, so those negatives will cancel out. And then we have r to the negative 1 minus negative 7. N to the 0 minus negative 3. And t squared minus negative 4. Now, when we rewrite it, it's already looking a bit simpler, and I'm a little less intimidated, because when I first looked at this problem, it looks a little scary with all those negative exponents. So don't get intimidated on the test. First, rewrite it with your subtraction. Now, when we do that, those negatives cancel out. We get 6 over 10. R, negative 1 plus 7 is 6. So r to the 6th. N, 0 plus 3 is n cubed. And t, 2 plus 4 is 6. Now, I don't want to really leave it like this. The proper way I want to write it is first by simplifying my fraction. And I will rewrite it as 3r to the 6th n cubed t to the 6th over 5. Now, if you're wondering where did the 3 over 5 come from, I divided 6 by 2 and 10 divided by 2 to simplify my fraction. So our answer is 3 times r to the 6th n cubed t to the 6th over 5. All right, let's move on to some new problems. So the next one we have, I see that I have division. I also have a power on the outside of the parentheses. So this is when I want to make sure that I am distributing or multiplying everything inside the parentheses by that power. So for this first one, number 8, we're going to start, let's see if we can zoom in a little bit. We're going to start by distributing and remembering that when there is a power raised to another power, we're multiplying. So this will become 4 cubed p, and then 4 times 3 r, 4 times 3 over, now here's the part that can be easy to forget. When it's division and a power outside the parentheses, we distribute to the denominator as well. So this would be 3 cubed p to the 2 times 3, r to the 2 times 3. Now, when we simplify that a bit, 4 cubed is going to be 64. Then p to the 12th, r to the 12th. 3 cubed, 3 to the power of 3 is 27. P to the 6th, r to the 6th. Now, we don't want to leave a problem with any division remaining. So we want to make sure that we've simplified the fraction if we can, and then that we've simplified the exponents. So here I still have division of the same bases, so I need to subtract these exponents. So this will become 64 p to the 12 minus 6, r to the 12 minus 6 over 27. Now when I simplify that, I get 64 p to the 6th, r to the 6th over 27. And that's my final answer because I can't simplify 64 over 27. Now, number 6 is a little bit different because the parentheses are only on the top of our division problem, and the power of 0 is only outside of those parentheses. So this would be a situation where I'm going to distribute the power of 0 to everything inside the parentheses. So first I'm going to distribute, but we don't have to because we have learned since everything up here is inside the parentheses, the power of 0 applies to all of it. And when we raise anything to the power of 0, it's equal to 1. So I could rewrite this as 1 over 4w to the negative first power y squared. Now, I'm not simplified though, because even though I see that I don't have any more matching bases and no fraction to simplify, I do have a negative exponent. So we've learned when there's a negative exponent, to cancel it out, we need to move that base and exponent to the other side of our division problem. When we do that, the negative exponent becomes positive. So here, w to the negative first power is going to move to the top of our problem. That becomes w to the power of 1 over, and now it's no longer in the bottom, so we just have 4y squared left over. Now we would rewrite this without the first power when we simplify it. But I want to point out that the only thing that moves is the base that's attached to the negative exponent. Okay, so that's why we kind of pulled out the w and put it on the top to get rid of that negative power of 1. Now, number 7, the next problem we have, Again, I see an exponent on the outside of the parentheses, so I'm going to start by kind of distributing and remembering that when I do this, I am multiplying my exponents. So I am going to get 6 squared, a to the negative 1 times 2, b to the 1 times 2, over, and then down here, notice the parentheses weren't around the whole fraction. So this exponent is only being applied to the top part. And this exponent, the power of 4, is being multiplied or applied, to the base b with the existing exponent of 2. So when we raise that power to a new power, we're going to multiply 2 times 4. So let's simplify this. We get 36, a to the negative 2, or the negative second power, b squared, over b to the 8th. Now, from this point forward, we've got some simplifying to do because we have to subtract to get rid of our denominator. So this will become 36, a to the negative second power, b to the 2 minus 8. So 36, a to the negative second power, b to the negative 6th. So here's the deal though. Remember, we can't have a negative exponent. So this is going to become 36 over a squared b to the power of 6. Because we have a negative exponent, so we need to move it to the bottom. And you might be saying, wait, but we didn't have a fraction. Remember, there's always that invisible 1 underneath. So we moved our negative exponents to the bottom of our fraction or our division, and when we do so, they become positive. Next up, we have another problem with powers on the outside of the parentheses, so we'll distribute them. This will become a to the 2 times 2, b to the 3 times 2, over a to the negative second power, b to the negative second power. So a to the 4th, b to the 6th, over a to the negative second, b to the negative second. We're not done because we still have division with matching bases, so I have some subtraction I could do. I also have negative exponents. So I'm going to bring this down here, and I'm going to rewrite this as a to the 4 minus negative 2, b to the 6 minus negative 2. So when I do that, I see my negative exponents are going to become positive because I'm subtracting a negative, and I get a, 4 plus 2 is 6, b, 6 plus 2 is 8. So a to the 6th, b to the 8th. Moving on, next up we have some scientific notation. Now we've learned how to rewrite our scientific notation. When we have these problems, always read your directions carefully because here we want to evaluate the product and express our results in both scientific notation and standard form. So when we have multiplication of scientific notation, we're going to start with the numbers in the front. So I'm just going to multiply 8.8 times 3.5. We'll start there, and we get 30.8 times 10. Now I'm multiplying matching bases. So this is where we're going to add the exponents. So 8 plus negative 13. From here we get 30.8 times 10. 8 plus negative 13. Remember, use your calculators if you're unsure about your negatives. We don't want silly mistakes to cost us points. So this becomes negative 5. Now, you might be thinking, hey, we're done. But we're not because we aren't in scientific notation yet. We've learned we need only one digit in front of the decimal. So we're going to move the decimal one more place. So we're now in the proper form, but when we do that, we have to add 1 to our exponent. Since it's -5, that plus 1 becomes 10 to the -4th. Now that's how we would leave the scientific notation. When we rewrite this in standard form, we're going to start with 3.08. And because it's a negative exponent, we're going to move to the left 1, 2, 3, 4 times and fill in those missing gaps with zeros. So our standard notation is 0.000308. Next up, we have another multiplication. So we start with the numbers in the front. 1.35 times 7.2, and we get 9.72. Now I notice I'm already in the correct form because I only have 1 digit in front of the decimal, so that's good. So then I just have to figure out what to do with my exponents, and because I have matching bases, I'm going to add 8 plus -4. So my answer is 9.72 times 10 to the power of 4. There's my scientific notation. Now, because this is a positive exponent, we're going to move the decimal to the right 4 places. 1, 2, 3, 4. Fill in those gaps with zeros. And the standard form of this number is 97,200. All right, we're almost done, folks. You're doing great. Let's move on to just some examples of scientific notation with division, and then we're done. So we're going to evaluate each quotient now, and remember, we're going to write our answer in both scientific and standard form. So the same thing, we're going to first start by dividing the numbers. So 9.2 divided by 2. That gives us 4.6 times 10. And then I remember when I'm dividing, I'm going to subtract my exponents. So -8 minus -6, that cancels out. And we get 4.6 times 10 to the -2nd power. There's my scientific notation. So for standard form, the negative exponent tells me to move to the left 2 places and fill in the gap with a 0. So the standard form is 0.046. Our last one, again, we have division. So we get 4.8 divided by 5, which is 0.96. Times 10, the base is going to stay 10, and then we're subtracting 4 minus -5. So we get 0.96 times 10, this cancels out and becomes plus. 4 plus 5 is 9. Now, we're not in scientific notation because there is no digit in front of the decimal. It's a 0. Remember, our number that we're multiplying needs to be between 1 and 10. So I'm going to have to move my decimal to the right this time. So when I move the decimal to the right, I need to, to the right, I need to subtract 1. So when I move the decimal to the right, I'm subtracting 1. Before, on the previous page, we moved the decimal to the left, which is why we added 1. So to the right, we're subtracting, and our answer is 9.6 times 10 to the 8th power. Now we're in scientific notation, so we're just going to convert this to standard form. Positive exponent, I'm going to the right. 1, 2, 3, 4, 5, 6, 7, 8. Drop my decimal point there. Fill in the gaps with zeros. And then I'm going to rewrite it carefully. 9, 6, 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7 zeros. So there is my standard form. All right, folks, so you've done a great job sticking with me through this review. It will pay off on your test. But before I let you go, I just want to go over a few things that may or may not come up as bonus point trivia on the test. So you're prepared. The trivia I might be asking will be about Pi Day. So a couple Pi facts to know. First, Pi Day is celebrated on March 14th, which represents the 3.14 we use to represent this irrational number. Now, I want to point out it's irrational because it never ends. That's why 3.14 is an approximation. Einstein was the mathematician and physicist who was born on Pi Day. How perfect. In 1879. The pyramids of Egypt, even though not circular, which is what pi is typically referring to, they are believed to have been built on the principle of pi, which we find pretty fascinating. And lastly, within the first million digits, so that's a lot of digits, a lot of numbers. So within the first million digits of pi, the sequence 1, 2, 3, 4 does not appear. So in all of those digits, the numbers 1, 2, 3, and 4 do not appear in that order at all, which is surprising. So great job today, guys. I am proud of you for putting in the effort. It will pay off. So trust that you have done the hard work. Now you just got to show what you know on the test. Have a great rest of your weekend. I will see you in class. Bye, guys.